So welcome to the second part of section 1.2. It's the third video, but it's really the second part. The first two videos I took you through equations that really only had three terms. There was a term that had a variable in it, and then you added or subtracted something to that, and then it equaled a third term over on the other side. In this section, I'm going to take you through, these are definitely going to be multi-step equations where you're going to have more than three terms. And you're going to have, you may have even more than one variable term, but it'll be one variable, but there'll be more than one term with it. So we're going to do two types of problems. One's going to be where you need to combine like terms, and then the other type of problem is going to be where we use the distributive property that I'll review for you in a little bit. In both of these, though, this is how the problems are going to begin, and then after we do a few steps, they're going to end up looking exactly like what you've been doing with the two-step equations. So if you look at the first two terms with the variables, these are terms where it has something with it. So you'll see there's a 2x with it right there, and 2x right there, there's a 5x right there. And those are terms that have variables, and you can combine them. It's like saying you have two bags of M&Ms, and the bags are identical. And then you also have 5 bags of M&Ms that also are identical. So altogether, you have 7 bags of M&Ms that are identical. The other type of term is where it's just constants. It's just 2, and that's 2 M&Ms. This means 5 M&Ms. In the first one, we have bags of M&Ms, and we don't know how many are in each bag. But we can then multiply them and figure out how many there are altogether. So as an example, let's say that there are 100 M&Ms in a bag. Then we can look at that and say, okay, if there are 100 in each bag, then this would give me 200, and then this would give me 500, and altogether that would be 700 M&Ms, in other words, breakfast. Or we could say, well, if I have 2 bags and I have 5 bags, then altogether that's 7 bags. And if each bag has 100, then that would become 700. Hey, same answer, because that is how it's going to work. And you can work with it either way. With the other one, 2 M&Ms plus 5 M&Ms, that's going to be just 7 M&Ms. So let's take a look at a problem that we can work out. So first thing we want to do is identify what are called the like terms. And these are going to be where either it's the same variable or it's a constant. So if you look on the left side, we have 3 terms. We have the 6x, we have a 3, and we have a negative 2x or a minus 2x. So we have 3 terms, but 2 of them are basically the same type of thing. We have the 6x, which again would be like the 6 bags of M&Ms. And this right here means we're going to owe 2 bags of M&Ms. So if you have 6 bags and you owe 2 bags, then altogether you're going to have 4 bags left over. How many M's is that altogether? I don't know. But if you tell me how many are in each bag, then I can figure it out. It's just like if I use the earlier number of 100. So I would start with 600 M&Ms, I would subtract 200 M&Ms, and that would leave me 400 M&Ms. Now, with that 4x, we also have those 3 M&Ms left over. Altogether, so that's the left side, and altogether that's going to equal 17. Now if you look at this red equation, it's just like what you had before. This is a two-step equation. We have 3 terms. There's nothing to combine, so we're going to get rid of it just like we were doing on the earlier videos. We're going to first of all undo the adding by subtracting, and whatever you do to one side we do to the other, and then we're going to combine that, and we're going to get 4x equals 14, and then we're going to divide each side by the 4, and what you end up getting is 3 2/4, and you never want to leave a mixed number like that. You always want to simplify it down. So we're going to either call that 3 1/2, or we're going to call it 3.5. In either case, If we go back to the M&Ms, it turns out that this is actually the smaller than fun size. This is the micro fun size. There's only 3.5 M&Ms in it. I don't know what happened to the other half, but that's what we have. Again, you can double check it just like you did before. You can plug it back into the beginning, work it out, and everything, again, is just like what you've been doing. So now, let's try this one. And if you look at it, this one has 4 terms on the left side. 2 of them are going to have a variable, and 2 of them are going to be constants. So I'm going to have you do this on your own first. Combine the like terms. Remember that you want to keep the sign that comes to the left of it. Remember that if it's invisible, it's really a positive right there. So this is going to be a negative term, a positive term, and a positive term. You want to combine the x terms, you want to combine the constants, and then it's going to look just like what you've done before. So pause the video at this point, work it out, and then check your work. So let's first of all combine the variables. So I've got this negative 2x, so in other words I owe 2 bags of M&Ms, but I get 3 bags. Yay! So actually I can pay off my debt and I will still have 1 bag of M&Ms. Now I'm going to combine the constants. So this is a positive 7, invisible plus sign, with 1, so that means I have 8 extra M&Ms. Put it together, it equals 10. So now we're going to get rid of that first, undo the adding by subtracting, and subtracting 8 is the same as subtracting 8, and what we end up with is x equals 2, another micro fun size bag of M&Ms. Let's say it's 2 pounds, that'll be more fun. And then again, you can plug it back in and see if it works. So let's just do that really fast. So we have 7, we have minus 2, but that x is a 2 now. We then are going to add just 1, and we're going to have a 3 times a 2. And let's see what that equals. So this is a 7. This together, negative times positive, is negative, so it's minus 4. We have plus 1. We have plus 6 equals 10. So we have 7 minus 4 is 3, plus 1 is 4, plus 6 is 10. Yay! Did it work? Yes, it worked.